Hi, I'm Mark. Thanks for grading my managing machine learning project. So we are an investment advisory firms. Our method starts with asset allocation. We generally advise that they keep those assets fixed, but a lot of clients want to reevaluate their asset allocation, sometimes as frequently as monthly. They want to know our opinion on what we think the market will do, but we don't give opinions. So we are looking for various ways of giving objective forecasts, so they have some method of some kind of input to that decision. And so we think that there's an opportunity here to build a machine learning model that will attempt to predict whether the market, the S&P 500, will be up or down at the end of each month. So why is it valuable to why would this be valuable to our clients? Well, first of all, they would avoid losses. Capital preservation, that's a very important concept to many of our clients. And then the psychological impact. Investors and our clients are no exception, tend to react more harshly to a downturn. So even though we advise buy and hold, we need to do something for our clients that want to be more proactive. If you were to invest 10,000 in the S&P 500 over 30 years on a buy and hold basis, you do really well. 10,000 will become 5 times that amount, almost 6 times that amount. But imagine if you could predict with 50% accuracy when to completely sell stocks at the beginning of a month and then only buy stocks again when you have a prediction that the market will go back up for a subsequent month. If you could do that, if you had been able to do that over history with only 50% accuracy, 10,000 over 30 years would become 88,000. So that's a big difference. That's a $30,000 delta, meaning that you'd be 50% better off if you were able to predict with only 50% accuracy. So that's pretty impressive. Is it possible? Is this a good opportunity where there is a problem? Can machine learning solve it? Can machine learning help solve it? And does someone actually care? Well, first, we know there's a problem because our clients need to make asset allocation decisions, which is not easy, and they're looking for objective input. We think that with some preliminary testing that we've done, that machine learning might be able to predict with at least 50% accuracy whether the market will be up on a monthly basis. And of course, our clients do care. So there is a real opportunity here for machine learning. And then just looking at this business impact versus feasibility, we think the business impact, if we could do this, would be very high. Feasibility, we think, in order to get feasibility of getting to 50% accuracy, we think is maybe high. We need to test it more. But if so, then we're in this magic quadrant here where there's significant business impact and feasibility it's a feasible project. Business understanding. So we'll work through that on a point by point basis. The target user would be our advisors and their client. A problem statement here: investors need objective information. Investors want to feel empowered. They gravitate to advisors with the best analysis and the tools. Why this matters? Well, asset allocation is very important. And in order to make that decision about asset allocation, our advisors and our clients need objective information. Defining the problem. Again, how is the problem solved today? Mostly using heuristics. We provide third-party research, and these rules of thumb are good. This information is good, but our clients, they want to be even more proactive, and they want objective advice from us. So we're looking for ways to solve that. If we go forward with this project, how will we define success? Well, in terms of business impact, we would be looking for an average increase in the returns of our customer or our client portfolios adjusted for risk. Uh, out in terms of our business, we'd be looking for an increase in advisory fees, and our client base grow. Metrics, the outcome that we'd be looking at specifically would be an increase in the net promoter score, and the output metrics we'd be looking for. We'd be looking at that based on accuracy percentage, a precision measure, targets. Our target is to increase the net promoter score by 5%. And in terms of output metrics, if we could have a 50% accuracy on predicting the S&P 500 on a monthly basis, we know that our investor portfolios would improve, and we'd like a precision of greater than 70%. The constraints, well, predictions for the S&P 500 must be ready early in each month. Market data is timely, but economic data has lags, and some is not monthly. What are the factors that matter here? Well, we need to have domain expertise, both in terms of financial markets, but also in terms of economics. And we have CFAs, certified financial advisors, and economists on staff. Other factors to consider: economic measures, financial data, national and global political and other events, indicators of sentiment, indicators of how will we validate this approach? Well, we would use agile development for machine learning. So the solution concept, the machine learning model will provide predictions of whether the S&P 500 index will be higher or lower at the end of this month and the next month. The prediction model will be used by our advisors and clients. Our hypotheses are that the advisors and clients will make frequent use of the prediction model. It will help with asset allocation decisions. It will augment existing tools. The predictions will be easy to interpret and understand, and advisors and clients will find it useful. So we will develop this solution based on an iterative, agile approach, and using agile development, which we've done in software development, and iterative testing at each stage. First, with this just shows the steps that we'll go through. So with the mock-up, we'll create a mock-up wireframe to focus on business understanding, answering these questions. We'll work with a subset of data and validate this further. So we'll gather some data. We'll work with the wireframe. We'll validate the data, test the quality control, clean resolve data issues, and then do some initial exploratory data analysis on the data. The question there is, do our assumptions still hold up? And then we'll work with that small subset of data, and we'll work with a heuristic model. So using just the simplest rule of thumb type predictors of the market. Is that decision model good enough, or do we need something better? Then moving on to a simple model. So we've got the basic prototype, but we want to add a predictive model. So we'd start with using a simple regression model. The key thing would be, can we get to some kind of degree of accuracy and precision with the model that we have a reason to believe that if we go deeper into the modeling with more sophisticated techniques, can we get to 50% or better in our accuracy? So then if we're getting that indication, then the next step would be to move on to a much more sophisticated model if everything else checks out. So we frame the problem as a binary classification task, where the goal is to predict whether the S&P 500 will be up or down at the end of this month or next. So that's, as we've learned in this course, a binary problem, and we're trying to predict true positives or true negatives and avoid false positives and false negatives. You're going a bit deeper on that. You're testing for accuracy, and I won't spend a lot of time explaining this, but you could read it if you'd like. And testing for precision. Um, and we think that we would use a random forest algorithm most likely as the model, the algorithm that we'd be using. But we might also go to a gradient boost model, and then even if this is proven to be very valuable, then we might even move to deep learning and attempting to get to greater than like 70% accuracy. So the ML system design, we would have these three major decisions: cloud versus edge, offline learning versus online learning, and batch predictions versus online predictions. Some of the considerations would be latency and so on. So on cloud versus edge, minor latency is okay, but we must have it must be accessible over the internet from our website, and privacy of predictions is not a big concern. So we think we go with cloud in the system design, then offline learning versus online learning. Real-time learning and training is not important. We can easily monitor drift by just comparing the model's predictions to actual data, and we can retrain this model quarterly. So we think that offline learning is the best scenario. And in terms of batch predictions versus online predictions, new data becomes available throughout the month, and we want predictions with the latest data. So we need the ability to, for example, do a prediction for the end of this month and in the beginning of the month, but also if new data becomes available, do a prediction for the end of this month at the middle of the month when new data has become available. So we want online predictions. Major risk in production on training drift. Training data is the same as data used in production, so we don't see any risk there. Excessive latency. The model may become large, but a slight delay is not a big deal. The data pipeline, though, is what has some risk. So we think that we can address that by processing the data nightly. So it's always the latest data is always available each day with the pre-processed data. Data drift is potentially a big issue. The economy evolves at a moderate pace, but the business environment changes quickly, and there are always big world events. So that's a major risk. And so we think that to address that, we need to retrain the model quarterly. As far as concept risk goes, the patterns learned by the model might change. Relationships between features and target might change. For example, risk appetite for the market overall might change. And you see that in sort of the PE ratios in the stock market. So that's a major risk, but we think that we can address that by retraining the model quarterly. And the question is, what do you think? We want to know. I want to know what you think. So please tell me in the comments. Would you find this kind of prediction model to be useful? Would you trust the predictions? Would you understand that you do not need to be right 100% of the time to still increase your investment portfolio returns if we had a model that predicted with 50% or better accuracy? So let me know in your comments, and thank you.